Okay, let's have a look at why we should differentiate. Well, differentiation does a whole range of different things, but ultimately we're changing the dimensionality of something. So if it was a squared, it becomes a power of 1. If it's a power of 4, it becomes a power of 3. Power of 3, it becomes a power of 2, and so on. So we're reducing the dimensionality. Well, but why? Why do we want to do that? Well, what we're doing is something incredibly useful. Whenever we have a function, and let's just, I'll just make one up here. Let's say it's y is equal to x. Let's make it 2x minus 3. There is my function. Of course, we can draw that up. Here we go. And I'll just make up something here. So it's going to be a y here and an x here. And so that means it crosses at negative 3. I'll just call this here negative 3. So that's going to be minus 3. And the gradient is 2. So for every time it goes 1 along, 2 up, 1 along, 2 up, 1 along, 2 up, 1 along, 2 up, and so on. And so what you end up with, if I can kind of get this going through all those points there, is something that looks like this. And I'll actually write this along here because I like writing it along the line I've just drawn. And there is the line of y is equal to 2x minus 3. I've put arrows on both ends, so it's not a line segment, it's actually a continuous line. Now, here's the important thing. Now, we've got a function. Let's now differentiate that function. So I'm going to find the differential of y with respect to x. So I'm going to have a power of 1 here. Well, 1 times 2 is 2. Reduce the x exponent by 1. So it was x to the power of 1. It's now x to the power of 0, which is just 1. So it'll be 2 times 1. Oh, and the constant falls away. So it just equals 2. What really have we found here? What we found, and if I could rewrite this another way, is the m value. M equals 2. The gradient of the curve, of the line is 2. And it's always 2. It doesn't matter whereabouts you look at this, which value we choose. It's 2 here, it's 2 here, it's 2 here, it's 2 here, it's 2 up here, it's 2 up here. And if we kept on going way down here, it'd be 2 here and 2 here and 2 here. The gradient is always 2. Now, you can obviously just see that by looking at it. But what say it was something that we couldn't tell just by looking at it? So let's choose a different one. I'm going to make this, in fact, I'll choose the one I had before. Y is equal, so we've got a bit of continuity here, x squared plus 7x plus 6. So now we've got a parabola of some sort. Now we can just draw that pretty quickly. And one of the ways of drawing it, of course, we could just factorize. And so let's just draw that, because I think it's rather a nice one to draw. Here we go. Here's my x value and my y value, 0. We know it's going to cross at plus 6. Here it is. It's going to cross at 6. There's my value of 6. Now, let's factorize that actually and just see where the points of intersection with the x-axis are going to be. Well, I know that y, let's make y 0, by the way, which this is the y equals 0 line. So that's also known as the x-axis. And I'm going to have my two brackets in here. It's going to be an x and an x. I know the signs are going to be the same, whatever these two are. Oh, and they're both positive. Now, I need things that add or subtract together to give 6. Multiply together, multiply together to give 6 and add or subtract to give 7. So multiplying to give 6. So we've got 1 and 6 and 2 and 3. Well, only 1 and 6 are able to produce a 7. Because 1 times 6 is 6, but 1 plus 6 is 7. So we could say either x plus 1 is 0. In that case, x is going to be negative 1. Or we got x plus 6 equals 0. So x is going to be equal minus 6. So I've got my 2 points of my 2 x-intercepts. So I've got negative 1 here and my negative 6 over here. So put negative 1 there and my negative 6 over here. So the graph will look like, and I'll try and draw this so it kind of plays out. It kind of goes like that, yeah? So there is my graph. I won't try and draw it on the graph because it's curving around a bit. All right. So the question now is, what happens if we differentiate? Well, if we differentiate, we find the gradient. The gradient at any point. Well, we found the gradient here at any point is always 2. No matter where you are on that curve, the gradient will always be 2. Well, let's see what will be true for this one here. And I'm noticing, of course, the gradient's constantly changing. Here it's like here it's like here it's like here, oh, missed, here it's here, and so on. The gradient's constantly changing. Well, let's have a look. So let's differentiate this. So I'm going to say dy over dx is equal to, now I've already stated the question, or the function, so I'm just going to now take this one. I've got 2 times 1 is 2 with an x after it. I reduce the power by 1, so this is going to be 2x to the power of 1. I don't need to write the 1 in. This is 7x to the power of 1. 7 times 1 is 7. I reduce the power of x by 1. It was to the power of 1. Now it's to the power of 0. Anything to the power of 0 is 1, so 7 times 1 is just 7. Now, I've also got this bit here. This just falls away. It's a constant. So I've got my m value. Now what we do is we call this the gradient function. Fn is short for function. So I've got my gradient function. That means all we have to do is choose any x value and we'll find the gradient of that point. So, well, a classic one, of course, would be right in the middle here. Now, if I was to say, well, what's halfway in between -6 and -1? Well, I could just add these 2 points together. -6 and -1 is going to be -7. So if I take my -7 and I divide that by 2, I'm going to have -3.5. And what we've just found, of course, is the halfway point. So the halfway point is -3.5. So let's see, what would happen if I put -3.5 for an x value? Well, m is equal to 2 times -3.5 plus 7. Well, 2 lots of -3.5 is 7, or -7. So I've got -7 plus 7, which is 0. We know that when the gradient is 0 on a parabola, we have found the turning point. We have found, in this case, we could call it the minimum point, or the vertex. Of course, the minimum point, so we know that -3.5 along, and we're going to be down a little bit. Now, in this case, you could be asked to find the point where the gradient is 0. Now, if we wanted to find the point, well, we can find the x value, and if you want to find the y value, all we do is we just say, right, well, let's put the x